right, if everyone has found a seat, I am very glad to announce our AI scale-up stories, GreenTech edition. Welcome everyone here at the AI campus in Berlin. My name is Georg, or George, whatever you prefer. I will react to both. I am the AI strategy lead at Engines here in our Berlin hub. Maybe some of you don't know what the AI campus is. The venue we are at right now, this is a co-working space. There are a lot of different companies here, from smaller startups and also bigger corporates. Basically everyone in Berlin who is doing something with AI has at least a foot in the door in this campus. And that's also why we at Engines decided to open up our second office here in the campus in this co-working space. So what are the AI scale-up stories? This is a series of events that is hosted by us, Engines, and also organized by us. And yeah, our idea is to have every 3 or 4 months at least one of these events. And the concept basically is that we invite CTOs, CEOs, co-founders of startups and scale-ups, mostly here from Berlin, so they can tell us about their journey, what they do with AI, how they leverage it, also what mistakes they made. So we can learn from that and yeah, hopefully take something home for our own projects and our own work. And so we're very happy to have our first GreenTech edition here in Berlin. We had a similar format about GreenTech in the Netherlands already, which was quite successful, but we thought Berlin is definitely the city for GreenTech, so we need an event like that here. And hopefully it's not the last one, but just the first one in a long series of events. So before we start with the actual presentations, I want to ask you a few questions. And to answer them, you just have to raise your hand. So let's just all raise our hands once to practice. Everyone putting one hand up so you get a feeling for it. Yeah. Okay, perfect. That's exactly how we're going to do it. So first question, who is here for the first time at the AI campus? Show of hands. Okay, quite a lot. That's cool. Welcome. Second question, how many people work with AI here in the room? Okay, yeah. Could be the same crowd, actually. I see very similar hands here. So who of you is working for a climate tech or green tech company? Okay, that's less than AI, but still a few. So let's see where the intersection of those two is. Who is working at a climate tech, green tech, and using or working with AI? Okay, this is really just a few. So let's get those numbers up. Maybe after this event, you will be inspired to either get green tech in your AI company or vice versa. So the last question, who's just here for the pizza and doesn't really care about the content? Okay, yeah. Okay, I'm glad it's just 4 people and I remembered your faces. So. All right, perfect. So I think we have a quite interesting crowd here tonight, and I'm also very much looking forward to meet you after our presentations and during the break. Regarding presentations, let's maybe have a look who is actually speaking tonight, who our guest speakers are. So we will start with Jessica Burley. She's an investor at Planet A, and she will talk today about AI's role in green tech and share some success stories and case studies. After that, we will already have a little break of 10 minutes, so you can grab another beer. And then we will continue with Guy Rigot from PlanBlue and Sebastian Prehn, one of our very own machine learning engineers at Engines. And they will tell us about how AI can be used for seafloor mapping for the blue carbon market. Last in our speaker setup, we have Steffen Schmitz. He's head of engineering at Y42, and he will talk about helping GreenTechs organize and collaborate on their data. And after those presentations, we will have another hour roughly for here to stay for you and get some drinks, meet people, connect, do some networking. So you're all very welcome to stay after the talks and just mingle a bit. All right, So before we actually jump to our first guest speaker, I would like to ask our CEO at Engines, Nick Yetten, to the stage. Nick co-founded Engines and Deploy, and he moved last year here to Berlin to set up our Berlin hub. And he will now tell a little bit about our company Engines and our focus on GreenTech.
Yeah, thanks. Yeah, good evening. Great to see you all here. I guess 5 years ago when we started the company, we also hosted some events. And then my main concern was like, I hope that some people show up. And now the main concern is, do we actually have enough chairs to get everyone in our seats? So that's great to see this change in the last couple of years. Engines founded in 2018. We are a company that is really focused on productionizing AI solutions. So we all, like me and the other two co-founders, Bastian and Maarten, came from a background in the data science world. So like a couple of years ago, it was called data science. Now it's called AI. But we all felt when working in data science that many companies struggled in a proof of concept phase and never really went beyond that. And that's why we founded Engines, to help mostly the tech world, so startups and scale-ups, to productionize and really operationalize AI solutions. Because only if you go beyond proof of concept, you can actually make the impact. And we try to make an impact, especially in a world where we think we can also contribute positively. So the industries that we focus on at Engines are mostly GreenTech, hence the event of tonight, marketplace, and also mobility. The move to Berlin was indeed last year. So last year we opened the office here at the AI campus. Super happy to be here. It's an amazing place where I think they do a good job in actually bringing companies together on one theme, and then it really works. So we don't only share pizza, we also really share knowledge. And in a journey like Engines is a project business, meaning that we build customized AI solutions for our customers. But of course, if we see something that we really believe in and want to have the IP ourselves, we are also open to build our own products. We did that once until now. That's called Deploy. We spun that out of Engines in 2020. So that's another company that now employs roughly 20 people, where we are building a responsible AI platform. A bit more in detail, what do we then actually do in the green tech or climate tech? Like if people have an opinion which of these two is the better to use on our website, please let me know. Now, what we mainly do is, on the one side, we build customized AI use cases. So you will see one of them tonight, but I think you will actually see many examples in the different stories tonight. But building customized AI use cases like battery prediction, climate monitoring, or energy prediction only works if you also build a scalable infrastructure around that. Because one thing is sure, the models will have to be updated over time. So you would really have to think of what is the machine learning operations, what is the data infrastructure that you build around those models. And the combination of these two, that is really our expertise. So the AI itself, but with a strong engineering and MLOps mindset. Next to that, we also help venture capital and private equity players. So investors, for instance, in the climate tech scene. And especially nowadays, we see kind of an increase in the questions that come to us to audit companies that have a business model which is based on generative AI, which I think for the investors, but maybe Jessica knows better, even more raises the question like, hey, it looks very interesting, but is it only a front end with on the back end an API call to ChatGPT, or is there actually a really valuable business model? That's, I think, a question that many investors have nowadays. Enough about Engines. Maybe just to set the stage for tonight, I think when we talk about green tech or green AI, there are really two perspectives, and I'm super happy that the speakers of tonight will, I think, also contribute to these two perspectives. So, of course, on the one hand side, you can leverage AI for green tech, right? There are so many companies working on green tech, though the intersection was maybe a bit small in the crowd for now. I truly believe that AI as a technology can really help those green tech companies to do better what they want to do, being having a positive contribution to climate change. But of course, that only makes sense if in the end, the AI that you build is also sustainable in itself, right? So it should not be that then your large language model that you use is so compute heavy that it's actually worse than the thing that you try to solve in the first case. So what can you also do in that era? How can you make the AI that you're building also sustainable? That's also something super important to think about. And I hope by having this event, we can, well, connect people in this space and make sure that both these goals will really be successful in the upcoming years. I think that's it from my side. Super happy that you're all here and to talk to you after all the talks, and I'll give it back to Georg to assign the first speaker.
Thank you, Nick. So our first speaker will actually be Jessica Burley. She's working as an investor at the Berlin-based VC Planet A Ventures. You want to come up here? Just a few more words. Yeah, please. So yeah, the stage is yours.
Thank you.
Maybe just one more thing you can.
Oh, perfect. Thanks. Hello, wow, what a turnout. It's amazing to see so many people interested in this topic. Really, really, really happy to see you all here. And thanks a lot for having me. I first of all want to put my hands up and say that I have a non-technical background. I probably know less about AI than anyone in this room, but I do luckily sit at this nexus where I get to meet a lot of people on the cutting edge of AI and green tech. And so today I'm going to be telling you about their stories and also about some of the problems that I see in climate, coming very much from the climate side, that could be relevant to those of you looking to solve some climate issues with your fantastic cutting edge technology knowledge. So maybe just a bit about Planet A to start off, so you know what we're about. And we're a venture capital fund. We raised our first fund last year. We closed it at 160 million, investing in early stage companies across green tech. So we have things in plastics and sustainable fuels and all kinds of hardware as well as software and AI, which I'm going to get to as well later. We are trying to be more than just a typical VC in that we're pioneering scientific methods. So we actually give our in-house science team veto power over all the investments we do. So if the impact is not significant, then they veto it, and they're using science-based methods to calculate impact. Of course, it's a little bit harder when it comes to things like software and AI, but the team is trained in life cycle assessments, so they're going very deep into all of the resources and emissions and biodiversity impacts, waterways, beyond just greenhouse gases. And yeah, we look across all kinds of climate tech. My focus is on energy and mobility, so you might see a few more of these in this presentation, but if there's anything you're working on as well that's outside of that, we'd be happy to chat with you afterwards. So yeah, and then beyond just the impacts, we're trying to be value adding to our companies. So we also have a platform team who are supporting companies as we do invest in that early stage with hiring strategies and comms, PR, leveraging our network, and really trying to be a helping hand to the startups we back. So sales pitch over. First of all, I just wanted to highlight how exciting these two trends are in transforming our economies and our societies, with a focus obviously on VC. So you can see that artificial intelligence has been growing from 2007 to 2017, and then more recently, I couldn't find any more recent data, so I had to add it on. That last year we got 50 billion, and just in venture capital investments into AI. So there's obviously quite a hype, and it seems like with Altman and Musk on the move, we're going to be seeing more of this in the coming years. Climate has had a little bit more of a rocky time, so we didn't have as high investments in the last 2 years as the years before, but cumulatively it's really growing. And we have faith that it will continue to, both because there's a lot of hundreds of millions of government funding going into it, but also a lot of dry capital from VC now having raised like many infra funds with over 10 billion each and overall multiple tens of billions, which on a personal note was really shocking to me because I've been 3 years ago working in this industry, and I had a list of all of the climate VCs. There was about 10 of them. and now we're seeing tens of billions in this. So it's really both really on a crazy trajectory, and it's really exciting to see that. So maybe also, as Nick mentioned, a word to the sustainable side of AI. It's got to be balancing out the counterfacts. It has huge resource uses. Everyone knows computational power, water use, and the mining of the actual critical materials going into it. That being said, there's so much potential in, I think, the overlap here, and also ways to mitigate these impacts. So I'm really excited, and I think we're only at the beginning of the journey of seeing how these two huge transformational changes are going to intersect. So maybe just a few case studies that I'm not going to dive so deep on, but wanted to highlight also interesting, is enhancing the accuracy of climate models with AI, optimizing energy use in buildings, homes, and industries, optimizing precision agriculture. So with better irrigation, we can use a lot less fertilizers and so on. And then streamlining waste sorting, recycling processes are super inefficient currently. And I think we're going to talk more about monitoring ocean health as well. But the ones that I wanted to focus on today is starting out with hard to abate industries, which is a term that we give to mostly sort of manufacturing of materials that really require high temperature heating, like cement or steel or glass or so on. And I think that this is super interesting for AI because currently cement production is remarkably complex. So there's a whole bunch of different inputs, fuels, raw materials, and different conditions of the state of the equipment and shift changes and different priorities like control limits and throughput. And at the moment, there's a huge differentiation between those who are the workers, the manual workers doing this, or operating it, who are very good at their job. And there's like about a 30% difference to those who are poor at their job. So yeah, AI can really be used here to deliver product quality while maximizing throughput. And we actually backed a company called Carbon Re, which is at the forefront of doing this. And they're essentially offering a SaaS solution, which is kind of a no-brainer also because saving fuel cost to the cement industries is like one of their biggest expenses. So for them, it's really a classic, yeah, it's a really clear case even without the climate benefits. And so they have a flagship software called Delta Zero, which is leveraging unused data to create a digital twin of each cement plant and then provide highly accurate recommendations for the operators and engineers to reduce their fuel use. And I think there's probably also potential, but they're definitely going to move also into steel and other hard-to-abate industries, but I'm sure there's also potential to go further than that, and maybe touch on that in a minute. But next one that I have is Optimal, which is essentially wanting to talk about the potential of AI in real estate decarbonization. So there's a current really big problem for large owners of portfolios of real estate in that they have thousands of properties with hundreds of thousands of data points on these individual properties, and competing decision-making criteria, so the local regulation, the particular building, and so on. And so it creates a high level of complexity, which makes all the real estate owners not actually want to do anything. So they've developed AI that analyzes the building data and identifies opportunities for energy efficiency and guides them towards more sustainable development practice. So it's a platform essentially that helps them make better investment decisions on how to retrofit their building stock. Next up, this is not a portfolio company, but is a super interesting one. So they're essentially discovering new materials for better energy storage as their first application, so like advanced batteries. But they could also do solar panels or other green tech applications. And essentially, using AI to find replacements for those by searching the periodic table and accurately modeling the different properties so that they can really accelerate the process of material discovery. And I think we've also seen that happen with a few more of the incumbents, like Microsoft's Azure Quantum Elements. And then, so those were my case studies of the sort of success stories. And then I wanted to also talk about some problems that I haven't seen solved. And that's by no means because they're not being solved, right? I don't see everything, but I would love to see more in this space, for example. So I think some areas, I'm going to start again by mentioning some areas and not going too deep in them. But some areas that could be super interesting is combining AI with synthetic biology. So you can create new organisms like plants that are super resistant or absorb more carbon dioxide or are more resilient, as we also got to like adapt to the climate changes that are coming. Or AI to develop nanotechnologies aimed at environmental clear up as well. So capturing pollutants or microbiomes and so on. And then to go a little bit deeper, one application that I think can be super relevant for AI is grid automation. So at the moment, there's a huge problem for grid operators in that they're under significant strain from everything being electrified. So we've now got way more demand, but at the same time, we're putting on renewables, which are way more intermittent and decentralized and variable. So they're getting increasing risk of disruption and blackouts, and that's stopping us from actually onboarding more renewables, and meaning that we are kind of tied to peaker plants, which are powered by gas, because we otherwise have to face the risk of a blackout. So one emerging area that could be really interesting is grid orchestration, and also bringing more level of autonomy to the grid, and simplifying those complexities. Another area that I think is a sort of solution with regrets is that we are going to exceed 1.5 in the coming decade, if not before. And so we will have to face the necessity of geoengineering for thermal regulation on mass scale at some point. And I think AI, advanced AI, that's a personal opinion, okay, not Planet A1. Advanced AI could play a really interesting role in managing these really large scale projects, essentially geoengineering projects like solar radiation management, and also monitoring the environmental impacts of that and predicting health outcomes and how we can do that in the most safe way. And then finally is in drilling. So there's two huge applications here, both of which we've actually invested into, which is geothermal and carbon dioxide injection. So geothermal is based on the idea that we really need some stable green renewable source. And the company we invested in is called GA Drilling, and they can actually access geothermal energy throughout the world. About 90% of the earth can access it because of their supercritical drills. That's sort of side note. The main point is that we could apply more AI here, I think, because the drilling process has a lot of critical real-time data, and the drilling equipment could be much better parameterized and navigate through those different rock types and reducing the wear and tear in the equipment and minimizing the also like side effect risks of drilling. If they had better applications of AI, and I think we've also seen this a little bit in oil and gas, where they've applied some better software. So I think that there's huge applications there as well. So that's it from me. And yeah, thanks a lot for your attention. Let me know if you have any questions. I think we're going to do now, but also if you don't feel like talking across the room, I'll be around afterwards, happy to chat, or you can also reach out to me on LinkedIn. Always happy to have people saying hi. Thank you.
So yeah, we actually have time for a few questions. So if you want to already ask something, now is the moment for that. I can walk around and give you the microphone if you're interested. Just raise your hand and let me know. Because if not, I have a few questions actually. So I will take the stage. Okay, here we have one.
Thanks for a great talk. I have one question, and it's more, let's say, what kind of scientific methods are you using to assess the investments that you're doing? I mean, because VC is inherently, like, you don't have much information and you can't predict the future yet. So yeah, what kind of methods are you using to mitigate it?
Yeah, it's a great question. I wish I could. So the impact team doing this, and they'll give you a much better answer than this. So life cycle assessments are quite an established way of doing it. Of course, we don't have much data on the company so far, so we have to project forward a lot, and we have various methods of modeling that. And if you're interested in digging deeper, I can also direct you to our website where we publish all of our white papers online, so you can actually dig into it. And of course, if there is a company a bit more established, we can go much deeper, like our geothermal GA drilling is a 300-page document because they actually have their drills ready, right? And they're using materials already. So we invest in that Series A, so they're a bit more developed. And then we can go very deep. But yeah, otherwise it is, of course, a pretty big company that barely have a business model, so it's hard to know what impact they already have. So a lot of it will be projection, but we're still trying to take that with a rigorous eye and really quantify what that could mean in a certain range.
Thank you.
Any other questions?
Thank you for the speech. One question. For new investments, do you assess AI capabilities of the team? That's it.
Good question. Yeah. So it depends is the answer. It really depends on the company. So of course, for Carbon RE, the background is very technical because they're using like deep reinforcement learning models. But for other companies, we also invest in a whole bunch. We've done 22 portfolio companies, and I think maybe 4 in AI. That being said, I think there was an interesting report recently by P9 who did a huge study of all investors in SaaS. And now really hot topic is having an AI strategy, which is going beyond, as you said, just using ChatGPT for your emails. So I think that there's definitely, as an investor community, a lot more focus on having those capabilities. But it's not like a hard requirement, only if they're building something AI-based. Of course, we need to see that capability in the team. Does that answer your question?
Sure. Okay, who else wants to ask something?
Thank you. So I'm completely new to this field. I'm actually from education technology. So just curiosity brought me here. And what it made me wonder here is maybe you could share a story about economic viability, because so obviously you are on a mission, but have you ever experienced or one of your portfolio companies experienced some tension between economic goals, profit, and all these honorable goals? Would be really interesting to hear about something like that.
Yeah, happily. So yeah, this is the question that often comes up. And we are investing in companies with significant planetary impact, but they have to have a super scalable business model. And I think we're quite clear that this is our role. We're VC. We have a 10+2 timeline, like a traditional VC. And there's many incredibly significantly impactful companies that cannot be that scalable, and in those cases they should not really come to VC. It's a sad case because of course we'd love to support them, but it's more for grant financing or philanthropy or government backing. Just to maybe touch on that a bit more is that we really still see that there are a hell of a lot of opportunities where you do get those hand in hand, and we really look for cases where, as a business model, as they scale, so does impact. And as we're going through this massive economic and societal transition towards, however you want to call it, net zero planet within our planetary boundaries, we are going to see that the winners of this kind of huge wave are going to be those who are actually really seriously having impact and not those who are greenwashing. And so we actually believe that our going more scientifically deep on that topic of whether or not they're really having impact future-proofs them a little bit to the regulations coming in and the public scrutiny coming in. And so those who are actually having that impact and throughout their supply chain, they're environmentally friendly and they're having a net positive impact will be those who are really successful in this transition.
Thank you.
Okay. Thanks for the question.
So we have time for one more question.
Thank you. You mentioned the point of geoengineering, and can you, let's say, drop more light on geoengineering by giving a few use cases in which AI can be used? And why do you personally think that AI is so beneficial there? Thank you.
Yeah, really. So it's super cutting edge, and we don't invest in these from the current fund. So I don't have that much contact with the people working on it. So I'm not going to be able to give you a super in-depth answer. That being said, I suppose it's similar to general climate models, right? AI has been really useful for modeling climate data and getting more accurate there. And so if we're tampering with the climate to do some kind of solar engineering, we're going to need to have the most accurate models possible. So that's where AI could come into play in my vision of it. But I'm sure there's many ways that could be useful that I'm missing as well.
All right. Big thanks to Jessica again.
Thanks for having me.
So now we would actually have a short 10 minutes break where you can grab another beer and just get up if you want. I will put a timer. If the timer is up, we will start again. Thank you. I'm not joking. What a crowd. People who are
yeah, I'm looking to see the progression. Yeah, last night we just went over. Yeah, okay, no, I haven't. Nothing. Yeah, but we have to line through like. Curious to see.
Yeah, same.
I think it fits quite well.
I think it's also, don't say much aloud, with the core of our industry. The others, and I mean, when you guys on different levels. Yeah, I think it depends on the crowd. Yeah. They understand.
I was curious to know what would be the trigger point.
I think that really helps.
So let's also our best. How do we just try to layer data is the right understanding. Okay, but this topic was the another part as well. That's for Claudio from Rigot.
All right, we have 20 seconds left on the timer, so just grab a last drink and get seated again. That would be great. So please grab your drink and find a seat. Then we can proceed with our next very exciting presentation. All right. So for our next presentation, we have actually two speakers. The first one is Rigot. He is co-founder and CTO at PlanBlue. PlanBlue is a Bremen-based startup with over 25 employees that employs underwater hyperspectral imaging and AI for efficient and detailed seafloor mapping at scale. Our second speaker, who will take up the second part of the presentation, is our engine's very own machine learning engineer, Sebastian Prehn. And Basti is a machine learning engineer here at the Berlin hub, not the Netherlands hub, and he's an alumnus of the University of Groningen, where he graduated with a master in artificial intelligence. So please, a warm welcome for our first speaker, Guy.
Good evening, everybody. I'm going to stand here, I think. Perfect, thanks. Yeah, good evening, everybody. Thanks, everybody, Engines, for having me, Nick. Basti, also Georg, thanks for having me here tonight. Yeah, we work with Engines, and we are a company that does AI-driven seafloor mapping for the blue carbon market. Now, I know that might be a bit vague, so let me go into a bit more detail there so that you have an idea of what we do. I'm going to read this out to you, and I'm going to come back to some of the terms you see there. So we combine hyperspectral imaging, precise underwater navigation, and AI-based automated data processing to ground truth, aerial, and satellite imagery for blue carbon projects. Now that's a big sentence. I'm not going to go into all the details there, but there are a couple of things in hyperspectral imaging. I don't know if you know what that means. Shortly, we look at the seafloor. We do Earth observation. Let's start there. We do Earth observation. We look at light coming from. We look at the Earth in the optical spectrum. So many of you are familiar with Earth observation. It's done from satellites. You can do Earth observation on satellites. You can do it from aerial, from airplanes. You can do it on the ocean floor, and we take it underwater. So what we do, we make maps of the seafloor optically. So we take images of the seafloor for looking how the seafloor is doing. So all this stuff has been done above ground already for years, decades even, and we take it underwater. And you see here this inverted pyramid, and that's important because all the way at the top is satellites, space-based Earth observation. If you go down, like I said, aerial imagery. Then you have on the sea surface, hydrographic imagery by sonar, by ships on the surface of the ocean. Then you take it underwater, robotics. And then when you take it all the way down, you look at the very high detail on the seafloor. So we have people sitting, taking measurements at the seafloor. We sit right above that. And that's important because that data is necessary to provide ground truthing for all the layers up there. So we, in the end, can say what a satellite sees is actually what is underwater because we've seen it with our own eyes, so to say. And that's what we do. That's what ground truthing is. So I'm going to stop there. You can ask me a lot more questions on what exactly we do, but otherwise we cannot get to the AI part of this presentation. That's why we're here.
Blue carbon.
Good point. So blue carbon is stored in plants, as we all know. Carbon is also stored underwater. In the case of seagrass, for instance, seagrass absorbs CO2 a lot more efficient than above the ground, 30% more efficient than in trees, for instance. There is a big thing happening now with blue carbon projects where they plant seagrass meadows underwater to store carbon. Those needs to be monitored, and that's also something we do. Thank you for that question. Good clarification question. Here a little example of what that means. So this is an image from a satellite in this case. You see a lot, but you don't see a lot of detail. Now you can zoom in, and you will see some of the data we took. So you zoom in, and there you have a very high detailed picture of what is on the seafloor. You see coral heads there, you see a little ray sitting even there. And on that you can do classification. What are we looking at? How healthy is it? And that's what we do, in short. This picture is also on our website, so if you want to look at it again, please go ahead and have a look there. So what do? We get this data, we get this hyperspectral data, we get this other normal imaging data, also normal RGB imaging data, and from that we derive data products. So we derive layers of information from the data we collect. I'm not going to go into detail on what these are, but it's health, it's how much CO2 is stored in the stuff we're looking at, the seagrass, the anything basically that's there. How high is the seafloor? What's the percent coverage of seagrass underwater? Now that we get there in two big steps. One, data collection. The data does not exist. We cannot get it from satellites because it doesn't exist yet. It's never been collected. So we collect it ourselves. We built it. So we don't only do AI, we are also a hardware company. We built the whole chain. We built the machinery and we built the data processing. Step one is collecting data. Up until now, diver operated. So we built a device that a diver operates underwater, swims underwater, collects data. Of course, doesn't scale very well. We're very aware of that. We're putting the thing in robots, so it can be done automatically. In about 2 months, we'll have the first test going on with an AUV, autonomous underwater vehicle in this case, which will be used for scanning 4,000 kilometers of Italian coastline. the Italian government wants to see all their seagrass meadows mapped, we're going to help them with that. Not alone, but we'll be part of it. That's step one. Then step two is process all this data. We collect optical data. We collect hyperspectral optical data. So that is a very large amount of data that needs to be processed. So we need to build an infrastructure for that. What you see here is just a high-level overview of our infrastructure as it is now. All the way on the left, the data comes in from our device that collects the data. It needs to go through a lot of processing steps to end up in the data products that you saw earlier. So we're at an AI event. Where does the AI come in? For now, in our case, quite late in the process actually. AI is part of our view, but it's not the only thing we do, like I already said. In everything what we call pre-processing. So we get the raw data from our devices. It needs to go through a lot of steps to get to a data product. The AI comes in at the end. So we do classification problems, image classification problems. That's of course where AI has proven its worth. That's also where we use it. That also brings me to the next steps, and I'm getting closer to the part where Basti is taking over, where engines helped us. In our case, data processing, we can still call it data science actually, in our case, even though Nick said that's the old term. For us, it's still very applicable, because for us, data science encapsulates a lot. We don't have only AI, we have biology in there. We have biologists who know a lot about seagrass and all the processes that are happening in there, that look at, okay, this is seagrass, is it healthy? I don't know, I'm an engineer. You need biologists to help you with that. Then there is all the data ingestion. We have a big part of physical modeling going on. Light travels through the atmosphere, through the ocean. Every medium has an effect on light. You need to model that light. So we have a lot of physical modeling going on. Then there's photogrammetry, stitching all images we take together. And then there is machine learning and AI somewhere also in that whole stack of technologies that we use. Not all of these people that do that are engineers or even good programmers. Some of them are not. So, but it is essential. They all have their expert knowledge that we need. It is essential that all the data as it flows down through that whole pipeline, that it's an efficient way, that everybody can do their work efficiently. Otherwise, at scale, you cannot try stuff out. It will grind to a halt. Especially when we need to process 4,000 kilometers of stuff. That's a lot of data, and it needs to go efficiently. And that's the scaling problem. It's always easy to do it on a smaller scale, but then if you need to process efficiently over long periods, it becomes important to scale it out. And that's where we decided to get an external opinion in. We're a startup. For me, it's also my first startup. We're not an expert in everything. And we want to make sure that we're not making any problems that could be avoided just by have somebody with experience looking at it. And that's when we came into contact with Engines through one of our investors, with the co-founder of Engines, one of the co-founders of Engines, and we decided to have a chat with them to say, hey, have a look at what we're doing. Do you see any pitfalls that you think we can avoid, and help us with that? And that's what we did. And this is the cue for Basti to take over. Thank you very much.
Thank you very much, Guy. Certainly have big boots to fill. Yes, I would like to enter the picture with you guys, where also Engines entered the picture with PlanBlue, which was back in August 2023. And to give you a little bit of frame of reference, I didn't know all these things that Guy just told you about. In fact, I Googled what is seagrass good for just before meeting him the first time, and what is the blue carbon stock market actually also. But what we do at Engines is we first create an audit to figure out what is actually the situation, what might be potential in this case. And then we move over to development and collaborate with the company usually to work on what we figured out was a good thing to do. This is sort of what I was going to tell you about. at the collaboration with PlanBlue, we were really looking at how to scale up their business. And then there are certain things that I'd like to touch upon that all relate to the algorithms, such as how do they actually use AI to leverage their business case? And what are the MLOps operation procedures and the infrastructure that would make that actually capable to work at scale? Well, let's start with the algorithm, because that's probably what most people think about when they hear AI. So what does PlanBlue really do in a very, very oversimplified way? They grab the pictures from the seafloor, and then they cut them into small pieces of 10 centimeters by 10 centimeters. And then they have a machine learning model here, the AI part, to look at that little piece and say, hey, is this seagrass or is this sediment? Simple as that. Well, the model itself, if we zoom in on that, you don't want to reinvent the wheel, especially not if the other wheel builder is Google or somebody else. So you find yourself a foundation model that is already pretty good in doing computer vision stuff. And then you feed it with the labeled seagrasses images so you can fine-tune it towards the actual fine-tuned model use case that you want to have, understanding what is seagrass, what is sediment, and what is everything else that you can find underwater. That guy knows way more about me than me. And well, if you're like me, your brain immediately starts thinking of things you can improve. You're like, oh, maybe I can look at the quality and quantity of the data, or maybe the foundation model could have a better use case relation already to begin with, or maybe a multi-model approach. Well, I like to tell you about a pitfall that I ran into myself there, but only if you all promise me to not tell anything to Nick or Guy, because I can't have them think incompetent. Well, I spent a lot of time on thinking about ways to improve that, and then it turns out, all right, there's this impact factor, and you got to think about how good are they already, and what would it really improve if I do these things? And it turns out PlanBlue does a really good job already in doing this part. They have a really high accuracy, and they're pretty good. So it turned out, yeah, maybe not there. And now you would be forgiven if you think like, okay, the machine learning guy just said the machine learning case is pretty good, so probably that's where it ended. But if you remember, there was this 4,000 kilometers of coastline that you just heard about. And the idea to scale up operations with AI drones underwater that can create probably way more data than divers can. There are some challenges here. And those challenges, pick three. We can assume there's going to be an influx of data growth, right? You'll get more data in. But also, if you want to work on all this data, probably you have to grow your team. And then there's PlanBlue specific requirements, such as if we collect this data, we would like to have our product in the end already 24 hours after making the first pictures, right? Those are all challenges that come to you. And when you want to scale up your operations, there are design principles that can help you combat these challenges. So I'm not going to go through these in detail because you all want to go home at some point, but there's a general theme here. You want to make things scalable, right? Be able to work on more data at the same time, basically. But then you also want to centralize and standardize your procedures, because as you're growing your team, you're going to have to onboard people, and you have a bigger team, which means more people need to collaborate, which usually means chaos. Somebody wants to make pictures of my slides. All right. And the third thing, you want to make your infrastructure that enables your entire case robust and foolproof, and also easy to maintain. So scalability, let's remember, centralization, and foolproof infrastructure that's easy to maintain. This is the architecture that we came up with. And now some tech people, big eyes. So for those people that find that intimidating, for now, just think about this as two parts that is mirrored in the middle. So we have these axes, then we have the development environment on one side, and the production on the other side should be pretty similar. But what really happens is Guy or somebody else at PlanBlue takes pictures of the sea ground. And then they come in here in the middle, where we have a one-stop shop of all the data that we collect. And then if you're a data scientist at PlanBlue, you can query this data and train your machine learning model on it. You're still in development, so if it doesn't work, no problem, nothing harm done. No harm done. Then you track your experiments because you want to learn still in like half a year, what did I actually do? Was it maybe this kind of parameter that gave around the perfect model? Once you're happy with your model, you use a version control model to push it into the production, and then you can serve your clients on here, and it's no problem if you break something in development because you still have this part. Now, that's the oversimplified principle. And then for the more tech-savvy people, let me just point out like 3 design decisions that they can, afterwards grill me about. So this, for example, stands for Rigot, which is a Python framework that helps you create modularized, reproducible code in data science. And it's something that was already in the use at PlanBlue. And we were just, that's great, guys, continue doing that. All we want to do is basically make it scalable by wrapping it into an AWS batch function so that you can like create it and make it on a bigger scale. And the second quite easy choice was MLflow. Because if you have a few data scientists, they can probably still over the lunch break talk about the best model that they have. But if you scale up your team, what you really want is make them able to compare the models because they share the same storage. So they build on top of each other's findings instead of finding the same thing over and over again. And then maintainability was the third thing I said. And for that, we chose to use Terraform, which is a infrastructure as code solution, which means instead of clicking through a lot of API tools on whatever cloud platform you use, you just write one script that's going to deploy your entire infrastructure in one go, which is really a pain to create. But once you've created it, it's great because it just works. And if it ends up stop working, you can easily find where the problem is and then maintain your infrastructure. All right. Hope you had enough time. Let's go further. I'll end on a little short Q&A session to myself, which I realize is a little bit cheating because I could prepare these, but you will be able to ask us questions in just a minute, and I just want to get the ball rolling a little. So, how much time did this project actually take? Great question. So we were there for the audit and the development. So the audit was about a month, and the development was 3 months, which means 4 months in total. But it's only possible really to build this all in 4 months because we were collaborating hard, I want to say, a lot with PlanBlue. So the developers at PlanBlue was actively working on all of this, and we were basically seeing what's their strength, what is our strengths, where can we help you, where can you help us. Would you want to collaborate with PlanBlue in the future again? Yes. What's question number 2? Not so cleverly disguised ruse to tell the CTO of PlanBlue that you want to work with them again. I would never. Okay, I would definitely do that, but not in this case because he already knows that we want that. And honestly, it's the other way around. If we didn't want that, we probably wouldn't have invited him. So, without further ado, thank you for your attention. Please, any questions?
Just have to wait for my microphone to turn on. Okay. Any questions? You can also address the question to one of the speakers, but you're also free to just put it out.
Hi. Maybe a question to the both of you. Have you thought about utilizing AI with the data that the company already has to maybe point out what are the best locations to look for seagrass or seaweed?
Yeah, so we don't have so you would do that on the more the areas that are covered, large areas that are covered, right, by either satellite imagery or by aerial imagery. And though the companies that do that usually already have an idea of where they build their algorithms on that to say, hey, this is, and those are often also AI based. So for us, when you're on the water, you see it if there's seagrass or not. So for us, it's not a problem of finding it; it's confirming it that it's there. So, but the AI is in use there.
Thank you.
Okay, other questions?
Hey, great talk. The question probably more to Sebastian. I'm curious about the data annotation part that you were talking about. Like, I guess if you're talking about scalability, that also has to be scalable, right? So what did you do there? And was the motivation to enable continuous learning? So the ones that you were probably getting wrong, you were focusing on that and then trying to improve your model and all.
Yeah, thank you for the question. I should probably figure that's going to be a question because it often feels like the holy grail, right? Label data is what you get to, or what you need to get really good AI algorithms. I'm afraid we haven't figured that one out yet. We use, or actually you guys use Label Studio, which is quite nice to label a lot of images. And if you have a lot of enough domain experts, you can create enough data sets to create models. But from the machine learning side of things, the only thing you can really do is make the learning more effective to maybe use the smaller models, do more experimentation about smaller models, but not really automized labeling yet.
More questions?
Thank you. This might be a really obvious, and I'm just not seeing it, but I'm super impressed, obviously, with the work you guys have done together. Fascinated by everything that goes into getting the point where you have that better mapping and understanding of the seabed. It feels like that's a really powerful thing, but I can't quite imagine. So what does that actually turn into in terms of the positive impacts that we can create because we've got that better understanding of the seabed? I'm guessing that there's some possibility for greater efficiency of carbon capture. Are we going to start planting more seagrass under the ocean? Like, what's the downstream upside of the work? Because I'm sure it's massive. If it's not confidential, I would love to know more about it.
Yeah, I can say something on that, of course. So indeed, I think it's twofold. There's, first of all, humans are not good at caring about something they can't see. We cannot see the seafloor, especially at greater depth. We cannot see it. Most people that don't dive have never seen what the seafloor looks like, or damaged seafloor. My CEO has a really good story of him. He's a biologist from background, and he always saw. He knows when seafloors are degraded, when they're not healthy, and those pictures were seen by people that never saw that before as, oh, this looks so amazing, even though it was completely dead. So making that visible is one side of the story. Making that visible so that people can act on it. Management decisions. You can have marine protected areas can be instated to protect areas, not just seagrass meadows, but also coral reefs, for instance, are a big one. We all know the bleaching stories, right? In the Great Barrier Reef in Australia. That's one side. On the other side, specifically to seagrass, blue carbon is a big thing these days. Of course, the whole carbon crediting scheme is something that's going to happen. There's also a lot of bad things that can happen to blue carbon. You know the stories from The Guardian made a big story not too long ago on that went wrong in rainforests. It will be there. The thing is, we need to have, if we want to do it well, we need to have good data. And so that's one part of it. The other part of it is by protecting, in this case, seagrass meadows, you protect it by, for instance, saying, okay, boats cannot anchor here because we want the seagrass meadows to grow. That stores more blue carbon, which is nice, of course. On the other hand, it also increases the ecosystem there. So you get healthier ecosystems, you get more fish, you get more for the food supply. Global food supply will benefit from protecting these areas and making them grow and making them healthier. So there are a lot of, there is the core one that is, okay, there's blue carbon, which is nice, and that will happen, but it has so much side effects that are there that make it an important thing in general, that we see what's happening and that we protect it and make it grow and replant it. I hope that answers your question.
Yeah, thank you. That's great. I think it feels like it's time for The Guardian to write an article on the underfloor.
Do we have more questions?
In the back.
Yeah, I'm gonna go in the back.
Hey, I'm Claudio from Ridergy, and not that it needs any explanation, but just I'm curious, why did you pick an external agency and in particular engines to work with you to do that? And for example, not do it in-house?
Yeah, so we do a lot in-house. Like I said, we're a team of 25 people. But we do hardware, we do software, we do a lot of things, and we're quite thinly. Our expertise layers are quite thin. We don't have 4 people working on AI. We don't have 4 people working on mechanical engineering. We don't have 4 people working on underwater navigation. Those are all single people. So what we wanted, there were certain areas where we were comfortable with what we're doing, of course, otherwise we wouldn't do it. But there was just something, okay, we need to do this, we need to do it well. We don't have a lot of time to do it well. And if you make, especially in this infrastructure space, if you make the wrong choices in the beginning, they're going to be a lot harder to fix later on. And that's a pitfall we wanted to avoid. And we knew, like I said, we knew engines through one of our investors. And we said, hey, we think this is a really important added value at this moment for us as a company to have an external company who has experience with this, who've seen this in multiple other companies, to have a look at this and see how should we do this? What do you think is the best idea here? And a lot of the things we thought that we did in-house proved correct, like Basti said, and there were no comments. Other things we had really great ideas. Like, hey, yeah, this works. Technology selection also is one of the things. You can spend hours and hours and days and resources on technology selection, and then in the end, yeah, it might work or it might not work. You might, and that just helps a lot to have external people look into it, and it helps implementing it also. Which is the other thing, we would not have had enough resources in-house to implement it. And hiring, I don't know if takes time, and it's I'm gonna use I'm not gonna use the word here, but it's not it's not always easy. Let's put it that way. So that is why we chose this route, and I think it was the correct one for us. Very helpful.
Okay, one last question. I'm gonna go over there.
Yeah, thanks for the effort. Looks like you're now starting something, so you're not really covering the full sea yet. But I can see that maybe in 5 years we might have satellites flying around the sea or the ocean. And the question is how you want to share also the data you save for taking action, and to not just build a big database of seaweed.
Yeah, so that's it's a very good question. Thank you for that one. So we started PlanBlue really from the core of wanting to do something good for the world. That sounds like a really cheesy statement, but that's why we started it. And open source data sharing is a big part of that. Where so there will be parts of our data that will flow into also to governments, for instance, to take action. And I could also really imagine that at some point, a lot of the data will be open source, so other people can take action. On the other side, you should have to be careful with that, because if you open source your whole data source, you cannot be certain that a company that wants to do deep sea mining also looks at it and say, hey, that's where we need to go. Let's go grab it. So yeah, there are, and that's the side of the dime we don't want to be on. So it's a constant question we ask ourselves, because in everything we do, there are a lot of ethical questions on, is this good for the world or is it not? And there's a big gray area there. And that's a constant conversation we have with each other in the company also, to make sure that we stand on the right side of the dime there. Yeah.
All right, thank you so much. So for our next presentation, we have to do a little technical change here. But I will use that time to already introduce our next speaker. The next presentation will be done by Steffen Schmitz. And Steffen Schmitz is the head of engineering at Y42. Y42 is a company that is actually part of Enjins partnership ecosystem. So we work with them together on different levels. And before Steffen joined Y42, he worked as a data engineer and site reliability engineer at Scalable Capital and on data products with SAP. And now, using his own words, at Y42, he combines his passion for data and infrastructure to create the data orchestration stack he dreamed of in previous roles. So give it away for Steffen.
Yeah, thank you a lot, and thank you for having me. I want to start with an anecdote about me being a data engineer at Scalable, because once a year someone came around and was like, hey, you work in data, can you pull a CO2 report for us? We want to know what emissions we have as a company, what we emit year over year, and how we improved compared to the last year. And somewhat surprising insight for me was there are three main factors for tech startups. One is the office, the people, and the data processing or the cloud infrastructure. So in the end, that's what we wanted to focus on. When we wanted to improve ourselves, we couldn't switch to electric vehicles because there were none. People, well, they continue to breathe and we want to grow, so they have to stay around. And the office spaces of the people, meaning, yeah, cloud compute was the one to go. And today I want to look together with you at how you can do that for your data pipelines that feed into different modeling cases, dashboards for your business, or even AI cases. So what contributes to bad data pipelines or leaky data pipelines? For us, it's multiple cases. One is you run the model all the time. You see that with our customers. You don't know when you use your data. You don't know when you need your data. Let's start by running the entire stack every 15 minutes. Second thing is, if you build everything, that's easy for you, but it also produces more compute. And the third thing is, someone created something somewhere, you don't know about it, but it's still around, it still eats compute time, happens all the time. So that, in the end, reduces costs, it reduces emissions, and that's also something that major cloud vendors noticed. For example, Google Cloud published their Go Green software guidelines, I think in August last year, telling you how as a data engineer, as a data scientist, as a machine learning engineer, you can improve your stack, you can improve your pipelines, first to save costs, but also to help the environment in doing so. And AWS mentioned the same thing in their keynote when they went on stage, presented a frugal architecture framework. They said, yeah, you save costs, but we save compute, we save energy. And each data center runs on power. They need to replace components constantly. So even if they buy certificates, replace that somehow, the emissions still go somewhere and need to be accounted for. I actually checked before this call what we emit at Y42 right now, because Google has a nice reporting there. And I saw that we're at about 25 tons per year, CO2 equivalent, which I learned is 3 times as much as a typical German produces. So I thought that was pretty good actually. But with more scale, with more usage, you also see how that increases the total cost. So making it scalable and scaling sublinearly with the use you see on the platform is what we want to achieve. And how can you do that? The first thing that usually helps is collaborate on a single source of truth. We see that in many cases, customers want to be safe with the data environment. They want to test things a lot so that things don't break. So you start with a development environment, production environment, and you notice, bad things still happen. So you had a test environment, staging environment, and suddenly you copied everything 4 times across different stages. The data still doesn't work, but you pay a lot, you produce a lot of content. So create one single source of truth. I like that in your slide actually, that you have one database, one storage layer for dev and production worked on shared understanding. So that was something we liked a lot. The second thing to do is have an inventory of all your assets. Understand what is there, what you run, and catalog everything meticulously. We see that with tools being added left and right, especially the customer success team is great at using Google Sign Up to go to each cloud vendor and do something with it. And we see that with some engineers creating scripts left and right that run and are not accounted for. So having one platform where you do everything that is in a gated way, that automatically catalogs everything, helps a lot there. And then finally, build what you need, when you need it, instead of running it all the time. So have an understanding, I need this data fresh for the board meeting on Monday, perfect, do the full batch on Sunday. I did a change there, just run the model or everything downstream. But don't do all the things all the time. And now I want to share with you how we try to solve it with Y42 on our platform. The first part is the shared lineage view that catalogs all your data assets, including sources, the models, the transformations that you make, and how you consume it in the end. And in the data catalog, you see what relations you have, what things contribute to the things that you use downstream. And we're also going to see that in a demo later. Second part is build what you need. And here we use DBT under the hood, the data build tool, which is a common open source library to do exactly that. We can model your transformations, and you can say, build me that part of the stack. For example, I want to have my Shopify source created, plus 2 steps behind. We have a few syntactic sugar fixes on top, like only building stale models, and I'll also get to that later. And then the final thing is, and I hope that works, our, let's call it secret sauce, which is virtual data builds. And here, what we try to do is do everything in one warehouse. Don't build a development, staging, and production environment, but instead we use one warehouse with virtual tables and then replicate Git version control on top of that. In that example, we start on the main branch. We have 2 tables, 2 views pointing to the tables. And now, if we want to make a change, instead of doing the change on dev, with everything being replicated, the only thing that we create in addition is a table for that change, and we keep the pointer from the previous asset. And because we do that, once we take the change back to production, we don't have to rebuild the entire thing, but we change to pointers, which makes changes instant. So this is great because you save on rebuilding. You only do it on your branch once, you bring it to main, it's instantly there, but you also get rollbacks, meaning if something goes wrong, you switch the pointer back, everything is still there, you didn't overwrite the entire table. And yeah, that's also something that our GreenTech customers see. Here's a quote from Rigot. They work in sustainable investing, so they are a platform where you can invest in climate projects. And they onboarded in December and are really happy with how they can collaborate on Y42 to make their data pipelines efficient, work on a single source of truth, and yeah, save compute costs and CO2 along the way. Now onto the risky part. Welcome to our product. Is this size good enough for the people in the back? I see some people shaking their head and others nodding. Let's make it bigger then. So here we start in our overview screen. We have sources, models, and exposures. Sources are things that go into your data pipeline. Models transform things, and exposures mean that's something that's consumed downstream by a dashboard, for example. And the first thing we want to look at is the lineage view. So in that case, we see how our data assets correlate to each other and detect the first issue, because this unused source doesn't point anywhere. It might still be computed, it uses storage. That's not ideal. The second thing is we might store a lot more data than we need. So we also integrated a kind of lineage view, so that helps you understand how things are consumed in your environment. We see the age column on our users is consumed a lot, also by our downstream models, but there's also a field academic degree that no one consumes, so we might as well drop it. Let's look at how this might work. Create a new branch. And at this point, the first magic happened. We're now in a fully isolated environment in your data warehouse. So you see your production data, but you can operate on it like you would in a development environment. So everything we do here is safe. First thing we wanted to do is drop the academic degree. Let's do that here. We can drop the unused source. And something that we also saw is, or we can see if we look at the preview, still we don't have any data in the 10 bucket and also in the later buckets here. So let's drop those as well. We can preview the query, and that runs on the production warehouse with the right data, but doesn't affect anything downstream. We can also look into what happens underneath by looking at the compiled query output. And this indicates the magic that we do underneath, which is using virtual ID tables that then map to jobs, that map to environments and commits. Now we can save that, do a commit. Oops. And we immediately see three new dots, here, here, and here. And that indicates that something changed, so those models are stale, meaning the latest build that is materialized on the warehouse doesn't point to the correct data anymore. Now the second part is, let's only build the things that have changed. And for that, we included the stale flag. We can execute that. And now we have a new orchestration job running. And we see in here that we built exactly the 3 models that we need. And once this goes to complete, which is hopefully soon, we can go back to the main branch and see nothing has changed there until we make the merge. Actually, let's do that right now. So we see here the build is ongoing. It started in 1952. If we go back to main, we're still in the state that we had before. So latest build was at 7 p.m. today, which was a scheduled one. And yeah, it shows you nothing has happened yet. Now after the merge, the instant materialization happened. So we see now it's at 1952, the job is completed, we only rebuilt what we need, we removed things that we don't need anymore, and we did that on a single environment without duplicating infrastructure, without recomputing things that were not necessary. And yeah, that's why we believe that this really helps you save costs, save emissions, and overall make for more efficient collaboration on the data side. With that, I would open it to questions, and thank you for your attention.